Hello friends, welcome back to the lecture series on linear differential equations. In the previous module we discussed simultaneous differential equations. In simultaneous differential equation, we are going to solve a system of equations which contains two dependent variables in terms of one independent variable. Let's take one example. 2 dx by dt minus x plus 3y equal to sin t and 2 dy by dt plus 3x minus y equal to cos t. These are two differential equations having dependent variables x and y and t as independent variable. So to solve this system, we can use different method of solvings, but right now we go for Cramer's rule. So Cramer's rule is, let's quick revise. Let a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. These are two linear equations having variables x, y. Then we consider x upon determinant of coefficients of y and constant terms in the denominator equal to minus y times determinant of coefficients of x and constant term equal to 1 upon determinant of coefficients of x and y. Then if we consider first and third ratio, we can find value for x, where x is equal to this determinant, upon this determinant, we get value for x. Similarly, y is equal to minus determinant this divided by this determinant. So we get value for y. Now let's solve this problem by using Cramer's rule. So for solving this, we consider operator d. So let d is equal to derivative with respect to t is the operator. Therefore, given differential equations can be written as 2 times d minus 1, x can be taken common, plus 3 times y, and we take function of t on left hand side, sin t equal to 0. Similarly, 3 times x plus 2 times t minus 1 y minus cos t equal to 0. So these are two equations. Now we apply Cramer's rule to these two equations. Therefore, by using Cramer's rule, we get x upon determinant of coefficients of y and constant term. In first equation, coefficient of y is 3. In second equation, coefficient of y is 2b minus 1. Constant term is minus sin t. And in second equation, constant term is minus cos t equal to minus y upon determinant of coefficients of x, that is 2b minus 1 and 3, and constant terms minus sin t and minus cos t equal to, the constant term is represented by 1 upon determinant of coefficients of x and y, that is 2d minus 1, 3, here 3 and 2b minus 1. So now we equate first and third ratio. We equate those two ratios. So this is for calculating variable x only. Therefore, x upon, so this determinant will be minus 3 times cos t minus plus 2 times t minus 1 into sin t. So this is on left hand side. On right hand side, if we simplify, this is 2b minus 1 bracket square minus 9. If we take terms containing d on left hand side, we get 4d square minus 4 times d plus 1 minus 9 into x is equal to minus 3 times cos t. Derivative of sin t is, so it is plus 2 times cos t minus sin t. If we simplify this, then we get, so this implies 4d square minus 4d minus 8x is equal to minus times cos t plus sin t. So if we take 4 common, so this implies our equation will be d square minus d square minus d minus 2 times x is equal to minus 1 upon 4 into cos t plus sin t. So this is the equation that we need to calculate. So we need to find complementary function as well as particular integral. T is d square minus d minus 2x is equal to minus 1 by 4 into cos t plus sin t. We consider the auxiliary equation. Let phi of t is equal to d square minus d minus 2 equal to 0. Let's calculate the roots of this equation. So this implies t is equal to, that is 2 and minus 1. So these roots are real and distinct. So this implies complementary function for x in terms of independent variable is c1 e raised to 2x plus c2 e raised to minus x. So this is a required complementary function for variable x. We denote it by equation number 1. So for calculating particular integral for variable x in terms of t, we operate auxiliary equation on function of t. That is, our auxiliary equation is d square minus d minus 2 and function of t is minus 1 by 4 into cos t plus sin t. So we take that minus 1 by 4 outside. We operate d square minus d minus 2 on cos t minus 1 by 4, that term. So it is minus 1 by 4 1 upon d square minus d minus 2 on sin t. So for the first part, shortcut method formula is replace d square by minus a square. So here shortcut method formula is d square is replaced by minus a square, that is minus 1. So after replacing d square by minus 1, the equation will be reduced. So this implies is equal to minus 1 upon 4 into 1 upon minus d minus 2 minus 1 is minus 3 into cos t. Same is the case with 1 upon minus d minus 3 into sin t. Then again we need to rationalize this. It is equal to minus 1 by 4 if you take this minus sign common from both the brackets. So it will be plus 1 by 4 we multiply numerator by d plus 3 and denominator by d plus 3. So we get d square minus 9 into cos t. Same is the case with plus d plus 3 into 1 upon d square minus 9 into sin. After replacing d square by minus 9, we get, so it is equal to 1 upon 4. This is d plus 3 times 1 upon minus 10 into cos t plus sin t as it is. So this will be minus 1 upon 40 into, let's operate this d plus 3 on this bracket. So derivative of cos t and sin t will be, so first derivative of cos t is minus sin t, so it is cos t minus sin t plus 3 times cos t plus sin t. Okay. If we simplify this, it is equal to minus 1 upon 40 into cos t plus 3 times cos t, that is 4 times cos t plus 2 times sin t. So this is your particular integral for variable x. Therefore, from above, x in terms of t is equal to complementary function plus particular integral. This implies x of t is equal to c1 e raised to 2t plus c2 e raised to minus t minus 1 upon 40 into 4 times cos t plus 2 times sin t. This will be the required particular integral for variable x. Similarly, we can find value for y. So again, for y, we can apply Cramer's rule, or we can use the given differential equations. Since the equation is 2 times t minus 3x minus y is equal to cos t. So from this equation we can identify y is equal to 2t minus 3 into x minus cos t. So this is nothing but 2 times derivative of x with respect to t minus 3 times x minus cos t, out of which x we have calculated in terms of t. We can differentiate x with respect to t, substitute those values here, simplify to find required value for y. So whatever we get, that will be the required solution. So I hope you find the derivative of x in terms of t, substitute it here and simplify. So from this, try to simplify this case.